Alright, good morning, welcome back from spring break. Hope you all were able to enjoy your time off. The next section we're going to be working on is section 7.1, which is applying the Pythagorean theorem. You should already be familiar with this actually, so we're going to ease into this by going over the Pythagorean theorem again. So we have our theorem here in a right triangle, and it does have to be a right triangle, that is important. The square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. So that means you have to have the square on all of these parts. So you often see it written as c squared equals a squared plus b squared, where c is your hypotenuse. And the hypotenuse is always the longest side in a right triangle, and it's also across from the 90-degree angle. I also like to write this theorem as hypotenuse squared equals leg squared plus leg squared. Obviously they're the exact same thing, it's just a little easier to remember than that your C has to be the hypotenuse, so you can do it either way, but your A and B don't matter. So example 1, we're going to find the length of the hypotenuse of the right triangle. So, we're going to start by writing down hypotenuse squared equals leg squared plus leg squared. So let's fill in what we know. They've already color-coded this for us. This is a leg, this is a leg, this is across from the 90-degree angle, so this is our hypotenuse. So we can write this as x squared equals 8 squared plus 6 squared. So then we'll have x squared equals 64 plus 36. So we have x squared equals 100. You're not done because we want x to be totally by itself. So as a reminder, when we have a square like that, to get rid of this square, we have to take a square root. Those are inverse operations. So we take the square root of both sides. And when you take the square root of x squared, it just leaves you with an x equals 10. That is our final answer there. So that is our hypotenuse. Example 2 is standardized test practice. It says a 16-foot ladder rests against the side of the house, and the base of the ladder is 4 feet away. Approximately how high above the ground is the top of the ladder? So we have this diagram here to help us out. The ladder is 16 feet. It's 4 feet away from the house, and we want to know how high the house is. So we first want to kind of dissect what do we have here. This is a leg, this 4 feet. Okay, and then across from our 90-degree angle is our hypotenuse. So the ladder is actually the hypotenuse here, and the side of the house is another leg. So when we fill this in to our Pythagorean theorem, we'll have 16 squared equals 4 squared plus, and whatever side we don't know we call x, which they did call x here. So then we just fill in 16 squared, 16 squared is 256, equals 16 plus x squared. I'm going to subtract 16 from both sides. So we'll have x squared equals 240. So then we have to take the square root of both sides. Don't forget that step. So the square root of 240, hold on here, 240, square root would be, and it's a decimal, that's fine. We can just round, it's 15.49, but we'll round that to 15.5. So our answer is D. And that answer should be less than our hypotenuse, so that makes sense. Actually, you could have done this without doing any of the math, because if 16 feet is our hypotenuse, you know that it has to be the longest side, and all of these options are longer than that. So actually, this could have been a problem where you just saw the only option that's less than 16 feet is D. For example 3, we want to find the area of an isosceles triangle. So isosceles triangles are not right triangles. So how can we alter them to use this Pythagorean theorem. So first of all, we're given this triangle here. We have 10, it's isosceles triangle with lengths 10, 13, and 13. Remember, isosceles have 2 equal sides. So that's basically looking like this, okay? And this is 13, and then this total is 10. We can't use the Pythagorean theorem on a triangle that's not a right triangle, but we could just take this isosceles triangle and split it straight down. Okay, and since it's isosceles, that means that this then would be 5 feet and this would be meters. Right, because these two would be equal then. So now we have 2 right triangles, so we can find the area here, but we do need to know what is this length here. So now I'm going to fill in, this 13 is my hypotenuse, so I'll have 13 squared equals my base, which is 5 squared, not 10 squared, 5 squared, because basically I'm just taking the area of this triangle first, but I need this length. And then let's call this, this median here, x squared. All right, and then I have to solve. So 13 squared is 169 equals 25 plus x squared. If I subtract 25 from both sides, we'll get 144, which is perfect, because hopefully you see that that is actually a perfect square. So when you take the square root of both sides, you get that x equals 12. Okay, so that means that this altitude or median is 12. So now we want to find the area of the triangle. Okay, so for our area of the triangle, remember area of a triangle is equal to 1/2 base times height. Okay, so we had to find the height. That was the part that we didn't know. And we used the Pythagorean theorem to find that height. So now we're going to find the area of this whole triangle. So you want to be a little careful here. When we fill this in, we have 1/2. Our base is actually 10, because it's the entire base, times our height, which we figured out was 12. So this equals 1/2 times 120. Half of 120 is 60. And then our units here, it was meters, so it'd be meters squared, because area is always in square units. So our area, 60 meters squared. And that's how you're going to find area of a triangle. All right, there's one cool thing here. I don't expect you to memorize these, but some of them you should start to recognize. We have this idea of Pythagorean triples. So a Pythagorean triple is a set of 3 positive integers. Remember, integers are whole numbers, a, b, c, that satisfy the equation c squared equals a squared plus b squared. So basically what this is saying is there's a whole lot of triangles that I could give you where you would solve and you're going to get a decimal. But it turns out that there's this set. It is unlimited. There's an infinite number here. But there is this set of numbers where they're going to be whole numbers when you solve for the Pythagorean theorem. And there's a way that we have these organized. We basically organize these into these main bolded ones. 3, 4, 5 is the classic one. If you have a triangle that's right with side lengths 3 and 4, you know the hypotenuse must be 5. Same thing if you have a triangle with legs 5 and 12, then the hypotenuse must be 13. There are things you can memorize. I don't suggest memorizing them, but you could. So from these bolded ones, basically, if you notice the second line is if you multiplied the first line by 2. The third line's if you multiplied it by 3. Fourth one's if you multiply it by 10, and so on. So basically, this is just saying multiply 3 by anything, 4 by the same number, and 5 by the same number, and you're going to have this new triangle that still will give you a whole number when you solve. So that's the idea of Pythagorean triples. So, example 4, we're going to use our shortcut of the Pythagorean triple. We want to find the hypotenuse of the right triangle, and we have these leg lengths 24 and 10. Okay, so I don't see 24 and 10 in my bolded area anywhere, but 24 and 10, it turns out we're going to use the Pythagorean triple. We can say a common Pythagorean triple is 5, 12, and 13. Hopefully you notice that. If we multiply by 2, we get leg 10, 24. Legs 10 and 24. So the hypotenuse, oops, can't write here, the hypotenuse is, and it would be, if we look here, 13, right? 13 times 2 would be 26. So the hypotenuse is 26 here. And it is actually a line here. But if you don't have a table on hand and you had memorized at least those bolded ones, that's how you could do this easily without having to solve anything, which is pretty nice. So you might want to have that table handy. Just tell me if you knew it was a Pythagorean triple. Tell me that you knew it was Pythagorean triple. Don't just put down the answer. That would be you showing your work for that. All right, that's all we're going to do today for section 7.1. If you have any questions, let me know. I have Zoom meetings this week. I will send out a schedule of those as well.